Hello, my name is Ridge Ricketts, and I'll be explaining my 2.4 problem for the set. So for this week, we have set 2.4, and so this one essentially builds off of the last one from last week, from set two. We learn about recursive bisection search, and so essentially what we ended up doing is revised our bisection search solution using the recursive function. So initially what I started doing, so here in set two, we have problem three. This was the one we did last week. And we are essentially repurposing this to get the same answer, but in a different way. So um, a lot of the framework is still there, but we're altering some parts, we're rearranging some things and adding some new things. So when we swap over, we have the same thing. We have problem four, but now we have the balance stays the same, 5,000 with 18 as well on the annual interest rate. So up here, we have calculate balance with payment, just as we did in set two. But now we take an additional parameter. We have right here, we have months equals 12. So this function calculates the remaining balance after 12 months given a specific monthly payment. And it has an additional parameter right there, months equals 12, that allows it to calculate the balance for any number of months, not just 12. So we have the if statement right here, the if else, which is actually different from problem two or problem three in set two. In set three, we had a for right here and then return, but things are a little different this time. We have in range 12 right there. So now we actually right here calculate the remaining balance after this month. Some of this stuff is similar, but it's kind of different because right here towards the end we have the recursive call for the next month. So a return calculate balance with payment. And so we have find minimum payment, which is also similarly still kind of similar, kind of different. Still trying to do the same thing, but a little different. We have the recursive method now. So we end up setting our lower and upper bounds for the bisection search. This is actually a little different than problem two. So we have lower bound equals balance divided by 12. And then through here, we don't end up using epsilon down here. We just go ahead and set that in the parameter. We didn't do that up here. The parameters are a little bit different. We go ahead and do these up here, which is actually optional, but I went ahead and just decided to have those parameters in there, and it just kind of helped with what I thought was the readability, just to have epsilon set up there. And I believe even if you don't have those up there, it'll just set those to 0 anyways. And then that epsilon to 0.01. So we get past this. This right here is pretty similar. Then we have calculate midpoint between the lower and upper. This is pretty much the same here. We have remaining balance. And then down here, when we adjust bounds on remaining balance, this is when it really starts to get a little bit different from two. Here we have if, elif, else, and then through here, when we're adjusting the remaining balance, right here we're adjusting the bounds on the remaining balance instead. And by allowing the find payment function to accept those optional parameters back up there, the code actually becomes more flexible as a result of it. And then down here we have minimum payment equals find minimum payment. That's final. And then down here, just as we did last week with this set, it's really right through here for this one that it starts to change up a little bit. And we actually end up getting the same answer as we did last week. 451.63, as well as we did here. 451.63. All right, that's mostly my explanation. Go ahead and let me know if I need to maybe be a little bit more in depth or if my explanation could be better. I'm always open to criticism, it helps me do better next time. And these videos are a little, can be hard for me to make. So that's it for that. Um, that's pretty much it. Thanks for watching.